Before we can bring our GUIs to life and make them respond to the user, we need to do a little housekeeping. We're going to take our basic understanding of swing widgets and reorganize our GUI in a more object-oriented way. Instead of dumping all our widgets in our main method, we can extend the JFrame class and treat our GUI window like an object. With this approach, our widgets are fields or instance variables of our frame, and our constructor can set up the frame, instantiate the widgets, and add them to the frame's layout. This approach gives us the ability to instantiate from our class multiple times, giving us multiple windows to use in our application. More importantly for the time being, it's going to make it a little easier when it's time to start dealing with events. Here's how a more object-oriented GUI
This program is going to use a GUI to get the name of the user and then display a simple personalized greeting. And before I forget, we do need to have those same two import statements that we've been using previously. So from Java X, we need the swing package. And from Java, we need AWT, which is Abstract Window Toolkit. It's not something I go deep into, but we're going to have a couple references there that will come from AWT. The whole idea here is that we want to start using inheritance and kind of an OOP-ish approach. So my class is called GreetingFrame because it is going to extend the JFrame class. So this is going to be the frame that we use as the basis of our GUI. And our fields in this kind of object-oriented approach is going to be where we put our widgets. So I'm going to start out by just declaring what all of my widgets are. And so I'm going to need a couple of labels. I will need a prompt for the user to tell them what they are typing in, right? So that's going to be a label that says, hey, put in your name. And what we've done in the past is we've sort of just gone right ahead and then instantiated that. There is absolutely nothing wrong with doing that, and a lot of people would do it that way. I'm going to just try and be consistent with my previous lessons on OOP, where at the top of my class, I just declare my variables, and I declare them as private because they are fields. And I'm going to then essentially set values to them or instantiate them in the constructor, just like I do with any other class that I develop. And so I'm going to put both my labels here on one line since I'm doing it that way. The other label I'm going to need is at the end when they're done, I need a label to display that greeting. Next up, I'm going to need a text field, or I call them a text box, but the class in Swing is JTextField. And I'm now using this prefix naming convention here, right? So the label that tells the user, hey, type in your name is called LBL name. Well, that gets paired up with a text field that goes with it, right? The prompt is referring to what they type in this text field. And so this prefix naming convention lets me kind of use the same root name, but say LBL for the label and TXT for the text field. So that's one of the reasons I like this approach. Again, the specific naming convention doesn't much matter. And the other piece we're going to need is a button for the user to click on when it's done. We could incidentally make it so they just hit enter or something like that, but we're going to keep it simple. So that's going to be button submit. So I've got those three fields, or instance variables I always call them, that are going to be our widgets. Again, in an object-oriented class, we are going to use a constructor to essentially set values to all of those widgets or fields. And the first thing we did in our old approach was we set the title of our frame in our constructor. And so I guess I could ask for that here, but what I'm going to do, partly to remind you that you have this option, is I'm just going to call the superclass constructor and I'm going to pass in my title that way. Now I don't have to do it that way because there is also the JFrame class has a set title method. So I could also just do it that way, but I'll do it with the superclass constructor call. And the next thing I'm going to do is I'm going to kind of configure the way my frame works. And so the one I always forget is set default close operation. For some reason, I never remember to get that right. And it's really annoying if you forget, because I just click the red X to close it when I test it, and then it's still running in the background. So JFrame.exit on close should give me the behavior I want. And now the next thing I want to do is set the size. So remember before I was saying frame.setSize? Well, that was because frame was an object that I had just created, but now this is the frame. This class is the frame, and so that's why I'm referring to this dot for that. The this dot is optional, but I like to use it. And that's part of the reason why, is to be consistent, where before we were saying frame dot, now we're going to say this dot. So I'm going to set size. I'm going to set it to 300 by 200. And the only reason I know that is because I fiddled with it before I started recording, so that I would know roughly what size I want it. And then I have to give it a layout manager, set layout, and I'm going to use FlowLayout, which I think is the only one I've even talked about at this point, so that it knows how to arrange these widgets when I start adding them to the frame. With my frame kind of set up and ready to go, I actually could start running it and testing it. And so here's where I'm going to break from the way I normally do things. So normally when I'm teaching object-oriented programming, I would go create a separate file that would be like my program with a main method, and it would instantiate a greeting frame object and go from there. This video, I'm going to be showing you a handful of different things that we haven't really talked much about before, so I'm trying to keep it as simple as possible. And only for that reason, I am going to put my main method inside this greeting frame class, and it makes me want to take a shower, because this is just not the way that I normally do it. I believe pretty firmly that we should have a separate program for this, but for the sake of your learning here and making it easy, I'm going to just do it right here. So I'm going to declare and instantiate my object here. So this is going to be it's not going to be a GUI, it's going to be a greeting frame. And I'll just call it frame, since that was the wording we used before, equals new greeting frame. And if I run this, it will execute, but I'll save you the suspense. I haven't forgotten, but normally up here we would also set this to be visible after we're done adding all of those things. I'm going to save that for when I'm done with my constructor. I'm going to say frame.set visible to true. And I think I should be able to run this and see my GUI so far, which is not going to be much of a GUI. It's just my window set to the size that I wanted. It's got a flow layout set up there, and it should close when I click the red X. But as I always say, I don't like to go long without testing my program. And honestly, we're pretty much done with our main method, at least for a long time. So I'm going to fold that up and get it out of the way and head back to my constructor. So the next thing I'm going to do now is configure my widgets. So first up is my label called LBL name. Now, remember in the other way, we sort of combined all into one statement, and we said JLabel LBL name. We're not doing that anymore. If I put JLabel, it's going to try and make a new JLabel with this same name. So now this is already an instance variable, so I'm going to say this.lbl name equals new JLabel, and then I'm going to put the text that I want, which is just a prompt to say enter your name. Next up for the user is that prompt goes along with a text field, so this.txt name, and again, I just like that those kind of go together. And sorry for the quick cut there, my dog started barking, so this is going to be a JText field. Now in the constructor call here, I could specify some text, so I could put a default value essentially. and that would be fine. It would display that, and then the user would be able to just type over it. But I'm going to leave it just blank for now. Next up is our button. New J button. I will just make that say submit. Not very creative. And then last but not least is our outputs label at the bottom, where we're going to output our message. Now, problem here is I don't know what my message is, so I can't put anything there. I could put some placeholder text in there and it would display. I could even put some placeholder text there and then make it invisible so that the user doesn't see it. But the easiest thing is just to leave that empty. Another one that I always forget is I have to add these widgets to my frame, and previously we would have said frame.add, but remember we are in the frame object now because that's what we are working on here. So frame.add instead is going to be this .add, and order counts, right? So the flow layout puts them in the correct order for us. So first is going to be the label, and then is going to be this txt name. I'm guessing most of you aren't bothering with this dot nonsense, but I don't think it's nonsense, and it's my video, so I can do whatever I want. So then there's the button, and then this dot LBL greeting. I think that is all of our controls. Let's go ahead and run that again. Okay, we're looking pretty good, but we have a couple of problems. One of them we can see and one of them we can't. They are related to each other. This little thing there is my text box. I think I can type in there. You can't see that, but I think it's accepting my input. Problem is the user has no idea what they're typing. They may not even recognize that as a text box and know that they can type there. What happens is the flow layout manager is going to make everything as compact as possible. So when I give the text to a label, it makes it exactly this size. It doesn't leave extra space. Same thing with our text field. Since I left it empty, it says, oh, it doesn't need any room, so I'll squish it down. We need to address that. So I could, like I said, I could put some kind of default text in there, and I could just make it really wide, right? That would do it. But then I would have that ugly text up there, and I'd have to make it visible and invisible and stuff like that. What I want to do instead is tell the layout manager the size that I want this text field to be. And so it's similar to what we did up here with the frame itself. But with a layout manager like this, we can't specify the exact size. What we can do instead is I can say this.txt name.set preferred size. And what I can do is say, this is what I would like it to be. There, incidentally, I could also say set minimum size. And the layout manager will try to accommodate that. But if it can't, because there's too much other stuff going on or too much in the way, it might not actually respect this request. But the set preferred size method doesn't take just a pair of numbers. It takes something called a dimension object. And so that's where we're going to put our two numbers. And the only reason I know to make this 250 by 25, again, is I sort of played around with some layout before I hit record. And so I think that's going to look about the size that we want. Now, I said there was also a problem we couldn't see. This was the one we could see. The J label has the same size issue, right? When it compressed everything to make it efficient, or as small as possible, as compact as possible, that J label was empty. So there's a J label there, but it's just teeny tiny. And I need that to be there so that when I put a greeting, it will display. Because the behavior here, if I change the text of that label, it doesn't sort of recalculate and redraw the size unless I tell it to, and that's just a pain in the neck. So I'm just going to do the same thing. I'm going to set a preferred size for my greeting label. And I'll just use the same dimension I did up above, 250 by 25, and I think that'll look all right. Let's go ahead and run this and see how it looks now. There we go. You just have to trust me that the label is there. I guess you don't have to trust me. I can prove it. I can bring receipts, right? There we go. There's my label. But it looks a lot nicer to the user if it doesn't have that information there. All right, so this is a good enough basic GUI for the program that we are creating here. And you may be thinking, well, gee, we haven't really accomplished much, right? I could have very easily written this same thing in our old way of doing it, just put it all in the main method, right? So I'm going to remind you that, again, my purpose here is to teach object-oriented programming, so it's important to me that we're writing this in kind of an OOP manner, so that's one thing. This does have a couple of other effects. One of them is if I wanted to, I could come down to my main method, which really should be in a different class if you ask me, but I could make multiple instances. I could have a frame 2, and then I could set them both visible and they'd both be on the same on the screen at the same time, or I could make one visible and then make the other pop up when the first one closed or something like that. It doesn't help us in this particular program, but it could be useful other times. More to the point though, this is going to help us, this object-oriented approach where we are extending JFrame, it's going to help us with the next topic we turn our attention to.
Let's revisit the idea of event-driven programming in the context of a GUI. The program is going to render the window and the widgets, and then it will wait until the user does something. Those somethings that the user does are called events, and some of them are really obvious, like clicking a button or checking a box. But there are all kinds of other events. Every time the mouse moves, that's an event. Hovering over a widget is an event. Typing in a text field is an event, and so on. So these events are happening constantly while the GUI is active. As developers, our job is to decide which events to respond to and exactly what those responses are. Maybe the program doesn't need to do anything when the user is just moving the cursor around. But if they click that button, the user expects something to happen. The mechanism that recognizes an event and triggers code to run is called an event listener, and the code it triggers is called an event handler. Event listeners are way more complicated than what we can do right now, but Swing, actually that AWT package I keep glossing over, can take care of that part for us with something called ActionListener. So we'll need to use that in our class in the same way we use stuff from JFrame. But remember that in Java, multiple inheritance isn't allowed. A cousin who's a close friend can't be both a friend and a family member. A class can only have one superclass. To get around the multiple inheritance problem, ActionListener isn't actually a class. It's something called an interface. An interface is like a partial class that establishes a set of rules. And by rules, what I really mean is that it establishes one or more methods that we have to create in any class that uses it. And instead of extending a class like we did with JFrame, we'll implement the ActionListener interface. We can let that take care of the listening, and we can focus on writing an event handler, which is what the program does in response to the event. Let's see how that works. We'll begin with another import statement. We need java.awt.event so that we can deal with some of this event handling stuff. And we're going to move on to this line of code where we define our class. And we've set it up to extend JFrame, and we know that we can't keep putting extends and extend other classes. Java only lets you extend one class. What we can do, though, is we can implement an interface. And so we're going to use the implements keyword, and the interface I want is called ActionListener. Now, right off the bat, we start getting an error. What an interface does in Java is it defines one or more methods, but it doesn't write any code for those methods. So it decides on a name and a return type and whatever arguments it needs, but there's no curly braces with the code that runs when that method is executed. The compiler can't deal with that. It needs to have code. So if we're going to implement an interface, we have to write the code for that method or however many methods there are. It's a little bit like overriding, except we're not replacing code that was written in a superclass. We're implementing it for the first time. We're writing the code for the first time. The method that ActionListener defines and needs us to complete is called actionPerformed. And that's actually our event handler, so it was something we were going to have to write anyway. VS Code recognizes what the problem is, and if I hover over that, the name of my class, it offers a quick fix. And the fix is to, write the code for the methods that aren't implemented. So you don't have to let VS Code do it for you, but let's go ahead and click that and see what it comes up with. I'll have to scroll down to the bottom to find it. And here it is. It has the override compiler directive because it does need to make sure that it correctly replaces the definition in our interface. And then it's put a couple lines of code in there that look really unfamiliar and possibly a little intimidating or scary. This is just placeholder code. What it actually does is it causes an error to happen if we try and run this code, because it doesn't want us to forget that we did that maybe in a hurry and then we go off and work on other stuff and we forget to come back with it to finish this. When we run our program, it's going to crash when it gets to this point. So we are meant to delete this code and replace it with whatever the real code is that we want. I'm also going to take care of one housekeeping thing that is just one of my little obsession things here. I'm going to put this actionPerformed method above my main method. I already feel weird enough having this main method in this class, as I keep saying. I'm going to scoot it down to the bottom because it really is kind of separate. Now, I just want to create a little personalized greeting and display it in that label at the bottom of my form. I'm going to write this with 3 separate lines of code, even though we could do it in one. And that's just because I want to be clear exactly what I'm doing and what the different pieces of this are intended to do. So the first thing I'm going to do is create a string variable, and I'll call it greeting. And I'm just going to put kind of hello and the first part of our greeting in there. And next, what I'm going to do is I'm going to add on to that string by grabbing whatever the user has typed into that text field. So I'm going to say plus equals, and now I'm going to retrieve this dot txt name dot get text. So as the name suggests, the get text method goes to that text box, text field, and retrieves whatever is in there. Now, if I've left a default string in there when I first created it, then it will get that back out. But if the user has replaced that with something else, getText is going to get that for me, and I'm going to add it on to my little greeting string here. And finally, I want to take this greeting string that I've created, and I want to display that in my label that I've created for that purpose. So I'm going to say this.lbl greeting dot set text. And in my set text method, I'm going to pass in the greeting that I've set up. So that makes sense, right? In the widget that is intended for the user to put in input, I'm going to get that information out. And in the widget that is intended to display my result, I'm going to set text back into it. Let's run this and try it out. We'll see what happens when I type in a name and click the button. I'll type in Tim and click, and nothing happens. Let's take a look at why. Remember that there are 2 different pieces of code that are involved in this event handling interaction. We've created the event handler, but we need an event listener to trigger this code and cause it to execute. So what we have to do is we have to find the widget that is related to this event, and we have to attach a listener to it. So I'm going to move up into my constructor here where I've done all of my work with these different widgets. And the widget that I care about for this event is the button, right? So I'm going to add a little space down here. I'm going to say this button submit dot add action listener. All right. And what this is going to accept as a parameter is an object that has this actionPerformed method that it's going to run. Now, that is set up this way because we could be using a different object. We could have a different class where we've defined our event handler, and we would need a reference to that. In our case, our actionPerformed method is right here. So we need to attach this listener to the event within this same class. So I'm just going to put the keyword this, as we've been doing kind of all along. Now let's try it again. Type Tim, click submit, and sure enough, it says, hello Tim. So now we're getting somewhere, right? This might not be the most exciting program in the world, but this little example has opened up a whole new way for you to write your programs. Before GUIs, you knew how to display text and get input in the terminal or console. With text fields, labels, and buttons, you can do the same thing, but you can do it in a GUI that looks a lot nicer for the user, and is probably a lot more what they are expecting when they open a program. Of course, there are lots more interesting widgets out there that we can use, and we'll explore those in another video.